Hello Shama, welcome to the session. Am I audible?
Yeah.
So we have completed the organic chemistry chapter, basically the foundation of organic chemistry. Only one part is left, that is the types of organic reactions. So we'll try to complete it today only. Okay, so there are many types of organic reactions. We'll study one by one. First type is our addition reactions. Okay, as the name suggests, in addition reactions, your two or more reactants combine to form a single product. It involves the formation of single product from two or more reactant molecules, as you know, it is addition reaction. Example of addition reaction is between an alkene and bromine. So it is my ethene, C2H4, plus we have bromine. And what happens? We have C2H4. One bromine comes here, then one bromine comes here, and then carbon valence is satisfied by hydrogen. So what you have observed, that alkene, it is converted into an alkane, right? And two reactants, that is alkene and bromine, they react together to give a one single product. So this is known as your addition reaction. Put it down.
I'm also done.
First type of reaction is addition reaction. Second reaction is elimination reactions. So elimination means to eliminate something, to remove something, right? So it results in the removal of a small molecule from a larger reactant molecule. Example is the dehydration of an alcohol. Dehydration means D means removal and hydration means water. So removal of water happens. A small molecule is water which eliminates from this alcohol by concentrated sulfuric acid. So this is my C2H5OH. If we write the distillate formula, C2H5 and OH. Now when you react it with concentrated H2SO4, this is a dehydrating agent. That means it removes water from your reactant molecule. So from this carbon your OH molecule is removed, and from this carbon your H atom is removed. Okay, and then we have a double bond here, and all the atoms are there, H and H. That means it is your ethene plus H2O is removed. H and OH, it gives me H2O. So elimination means that you have removed this small water molecule from your reactant, larger reactant molecule. Okay. Any doubt in this? Okay. The first reaction we have learned about is addition reaction. In addition reaction, two or more reactants combine together to form one product. And second reaction is your elimination reaction. In elimination reaction, there is a removal of a small molecule. It may be your ammonia, NH3, and it may be your water. That is your H2O. Third reaction is our condensation reaction. Okay, what happens in condensation reactions? It involves the first step where addition takes place and the second step where elimination occurs to form the final product. Okay, in condensation reactions, first step happens in addition reaction. That means your two or more reactants combine together to form one product. And after that, your elimination happens. So two steps are involved in condensation reaction. First is your addition and second is your elimination. So it is addition elimination reaction. That is your condensation reaction. Write it down. Condensation reaction is esterification, in which your alcohol and acid combines together to form an ester. Okay, so the name of the reaction is esterification. What happens in esterification? Carboxylic acid and alcohol. That means addition reaction is happening, right? Two or more reactants are combining to form product. Product is your ester. And there is a removal of a small molecule, that is your water. So this is your example of condensation reaction, or you can say addition elimination reaction. In the symbol language, you can write down RCOH plus R dash OH, and it gives you RCOO R dash plus H2O. So the next example is, so remember the sequence. First we have learned about the addition reaction. Second is elimination. Third is condensation. Fourth reaction is a substitution, and this reaction is very, very important. Substitution reactions are very, very important in this organic chemistry. So substitution reactions it involves the replacement of one atom or a group of atoms by another. Substitution means to substitute something, okay, to replace something. For example, the free radical substitution of alkanes by chlorine in the presence of UV light. So this is my methane, CH4, and this is my chlorine. You know that alkanes are generally unreactive. They show only two types of reaction. One is your substitution reaction, and the second is also the substitution reaction with chlorine. So what happens? One chlorine and one H. They combine together and form HCl. So you can write here CH3Cl plus HCl. So substitution reaction means that this chlorine, it have substituted the hydrogen of this methane. So it is called as substitution reaction in the presence of sunlight. Sunlight, UV light provides the activation energy for this reaction. And if you further do the reaction, then you have CH3Cl plus chlorine. Then what happens? One more chlorine, it will substitute this hydrogen of this chloromethane. So you have CH2Cl2 plus HCl. Similarly, write down the next reaction on your own. CH2Cl2 plus chlorine, it gives me what? So tell me the product here plus HCl. Substitute one chlorine of this chloromethane, dichloromethane with the hydrogen. You have to tell me the product here. What is the product in the third reaction?
Ma'am, I have a question about that.
Yes.
The reaction is CH2, Cl2, and then it's Cl2 again.
Yes, then?
So it would be CHCl3.
Yes, this is correct. So what was your question?
No, ma'am, I was just confirming. Sorry.
Yeah, this is correct. Now do one more reaction. CHCl3 plus chlorine. This is actually the final step. Tell me the product here.
CCl4.
Yes, very. So this is the end of the reaction now. CCl4 is basically the final product in this reaction. So this reaction have 4 steps. Substitution by chlorine, which we have discussed. Fifth reaction is your hydrolysis. Fifth reaction is hydrolysis. So as the name suggests, hydro means water, lysis means broken or breakdown. So hydrolysis is the breakdown of a molecule by water. Now we can speed up this type of reaction by adding your acid or alkali, as a catalyst. For example, hydrolysis of a halogenoalkane by water to give an alcohol. Okay, so this is the reaction of, this is an example of hydrolysis where the breakdown of molecule happens in the presence of water. So you have C2H5. Write down the displayed formula and it will be easy for you to understand. C2H5Br plus H2O. H2O is H and OH, right? Now it will give me C2H5OH. It is similar. You can see that it is similar to the substitution reaction, that bromine is substituted by alcoholic group plus HBr is eliminated. So it is an example of your substitution reaction, but it happens in the presence of water. That's why it is called hydrolysis reaction. Okay, hydrolysis with alkali is faster. It gives slightly different products. If you add alkali, then what happens? OH comes and attached to this bromine place, and then we have Na and Br as a byproduct.
Hey students! Interested in boosting your studies? Enroll now at Keddy Edtech. We offer online tuition for the Cambridge curriculum, grades 6 to IGCSE, AS, and A-level. Start learning with us today.
Reaction is our oxidation reaction, which we already have studied in the chapter redox, right? Oxidation is defined as the loss of electron from a species. How to remember this? Using a trick oil rig, where Oxidation is loss of electrons and reduction is gain of electrons. You can remember this by first letter of the word. However, in organic reactions, it is often simpler to think of oxidation state in terms of the number of oxygen and or hydrogen atoms before and after a reaction. But since this is higher level of chemistry, so we'll consider the oxidation by the use of oxidation state. If there is an increase in oxidation state, it is oxidation, and if there is a decrease in oxidation state, it is reduction. So let us see this reaction. This is your ethanol. This O, which is written in this bracket, okay, the square brackets, it is called as nascent oxygen. It is called as nascent oxygen. So what happens, it works is to oxidize the molecule. So when alcohol is oxidized, it gives us aldehyde. This is your partial oxidation. If it is complete oxidation, then it will give me acid, carboxylic acid. In partial oxidation, alcohol gives aldehyde, but in complete oxidation, your product would be carboxylic acid. Alcohol give me acid. So this is the partial oxidation of ethanol to ethanol using acidified potassium dichromate solution, K2Cr2O7 solution. Okay, you have to use this in oxidizing. It is an oxidizing agent, so you have to use this, which oxidizes another molecule and itself it gets reduced. Before the reaction, ethanol contains 1 oxygen atom and 6 hydrogen atoms. You can count. But after the reaction, ethanol contains 1 oxygen atom and 4 hydrogen atoms. Okay. So removal of hydrogen will happen, and removal of hydrogen is nothing, it is oxidation. Okay, so this is my complete oxidation. So in complete oxidation, your alcohol, it reacts to form acid. This is my carboxylic acid. Okay, so this O, as I already told you, it represents an oxygen atom from the oxidizing agent. What is the oxidizing agent we have used here? Tell me. Which oxidizing agent we have used in this reaction? Potassium dichromate, guys. It is potassium dichromate. Acidified potassium dichromate solution, whose oxidation number of chromium is 6. Okay. So it is potassium dichromate. The 2 in front of oxygen is added just to balance the equation, because there are 3 oxygen atoms in the left hand side of the equation, and in the right hand side of the equation there are 3 oxygen. To balance this, we have added a 2 as a stoichiometry for this nascent oxygen. So I'm writing 4 molecules here. You have to tell me the IUPAC names of this. First one is CH3CH, CH3, C2H5, and C2H5. Second one is CH3, CH, C2H5, C, C4H9, CH3, and CH3. Third one is CH3CH, CH3, CH2, H. Okay, so remember all the rules of the IUPAC nomenclature and then apply it. And the last one is Please solve it in your notebook and then tell me the answer. Let me tell you all the rules once. First rule is that you have to select the longest carbon chain. Second rule is that you have to select the lowest locant. Okay. For example, 224 is better than 355. If you add, then it should be lowest. And the third rule says that counting will start from where the branching is maximum. Because there are no functional groups, all are hydrocarbons. So these three rules are sufficient for you to write down the IGCSE. Okay, so what is the name of first compound, Shama?
2,3 diethyl butane.
Pardon?
2,3 diethyl butane.
3 what? Di what? Ethyl.
Ethyl.
Methyl.
Actually,
Then?
No,
butane.
ma'am, she said ethyl. She
She
said
said
diethyl.
butane. This one.
Yes, that's what she
Yeah.
said.
Here first rule is not applicable, that you have to select the longest carbon chain. What you are selecting only 4 carbon atom chain, which is not correct. Look again and then tell me the answer again. This is completely incorrect. Select the longest carbon chain in continuity. I can see there are 6 carbon atoms in continuity. So it should be hexane. Now what should be the groups which are attached? You have to tell me. See, 1, 2, 3, 4, 5, 6. So there are 6 carbon atoms. It should be hexane. Now tell me the prefixes. Yes, what should come here, Shama, now? If it is hexane, then?
Could you show me how is it in continuation? The 6 carbon.
You are not audible.
Could you show me how the 6 carbons are in continuation?
Okay, no problem. Just a minute. Okay, so I'm lighting this compound. Can you see this color?
Yes.
CH3, CH, CH, CH3. C2H5 we can write CH2CH3 by opening it. Here also we can write CH2CH3. Yes, we can write this like this, right? We have just opened the ethyl group. It is C2H5 only, right? It is C2H5 now. C carbon 1 and carbon 2, hydrogen 2 plus 3 is 5. So it is nothing, it is C2H5. I have just opened this C2H5 ethyl group to show you how the 6 carbon atoms are there in the root chain. Now if you start the counting from here as you have done previously, 1, 2, 3, 4, then there are only 4 carbon atoms. Okay, there are only 4 carbon atoms. But the first and the foremost rule says that you have to select the carbon chain with the longest chain, that means highest number of carbon atoms. So you have to see in continuity that if you select it from here, this carbon, then it becomes 1, 2, 3, and if I put 4 here, then it will become incorrect because then it is of no use, right? So I put 4 here. If I put 5 here, then also it is pentane. But if I put 5 here and 6 here, then it becomes my longest carbon chain. So I have to select this chain. All other groups are my substituents. So this is my longest carbon chain of 6 carbon atoms. And at the which position? 3 position and the 4 position, you have a methyl group. So it should be 3,4 dimethyl hexane. Is it clear? Any doubt in this? How to select the longest carbon chain?
Yes, it's clear.
Alicia, is it clear to you? 3,4 dimethyl hexane is it is okay,
Yes,
no?
it's clear.
So as I told you, practice makes a man or woman perfect. So practice it second part and then tell me the answer.
Hey students! Interested in boosting your studies? Enroll now at Keddy Edtech. We offer online tuition for the Cambridge curriculum, grades 6 to IGCSE, AS, and A-level. Start learning with us today.
So what is your answer, Alicia?
I said it's 2, comma, 3 trimethyl octane.
Let me check. 2,3,3 dimethyl octane. Okay. What is your answer, Shama? Alicia, how it is 2,3,3 trimethyl octane? Which carbon atom you have numbered as 2? Can you tell me?
Oh,
Which
sorry,
carbon atom?
ma'am. 3,3,4,4. I don't mean 2,3,3. I was just
3, 4.
thinking about it now also.
Okay. Yeah, I was also confused that which carbon atom you have marked as second. Have you done, Shama, this second part?
Which second part?
Pardon?
Which second part?
What she is saying, I'm not understanding. Please write in the chat box. Which second part? This second part, this reaction. Have you done writing the name of this reaction?
Yes,
What is your answer?
the same.
The same. 3,4,4 trimethyl octane, right?
Yeah.
Yes, it is correct. Because counting will start from this carbon. Okay, so 2, 3, 4, and then 5, 6, 7, 8. Right. At the third position, you have a methyl group. At the fourth position, you have one methyl and one methyl. So you have to write 3, 4, 4. There are 3 methyl groups, trimethyl and octane. So very good. Now solve the 3 part. Third part is this, third reaction. This is very easy. Tell me the IUPAC name of this compound. Here only one rule is applying. Start from from right hand side or left hand side?
Left.
Yes, very good. 1, 2, 3, 4, 5, 6, 7, 8. Now it is very easy. It is octane. What should come here? Why I don't know. Yes, Shama, tell me what should come here in the prefix of octane.
2,5,6.
Yes.
Dimethyl.
Yes, very good. 2,5,6 dimethyl-octane is the correct IUPAC name of this compound. Now quickly tell me the name of fourth part. Fourth part means fourth reaction. Counting will start from left or right?
Left.
Yes, very good. 1, 2, 3, 4, 5, 6, 7. It should be, what should be the IUPAC name then?
I'm not sure about like the group on the third carbon. Like, what do I call that?
Pardon?
On the third carbon, is it a dimethyl group?
No, it is CH2CH3. CH2CH3 is called what? Ethyl. CH2CH3 is nothing, it is C2H5 only, and C2H5 is ethyl.
Okay. So it would be 3-ethyl, 5-methyl heptane.
What do you think, Shama? Is it correct?
Yes.
Yes, absolutely, it's correct. Okay, so these are some IUPAC names which you have to practice. So let's wrap up the session here only.